All right, now let me continue the review. And I want to look at, where am I? Okay, let me get a new page here. I want to look at the problems from section 4.4, where you're adding and subtracting polynomials. And then we'll go on and do multiplication division on this one if we have time. So 4.4 was adding and subtracting polynomials. That's basically combining like terms. You just have to be careful on the subtraction problems. 4.5, 4.6, that was just multiplying polynomials. And we are not going to use special formulas or think of the 4.6 problems as anything different than what we had in 4.5. It really is not as good as just using the idea from 4.5. So don't go trying to memorize the formulas in 4.6. And then in 4.7, it's really two parts. Part one is when you're dividing polynomials, but you're dividing by a single term, a monomial. And then in the second part, part two, that's where you've got to do long division. And that I felt like I wasn't ready to put on the test next week. So your test will go through from 4.1 all the way through 4.7, just the part one, the problems dealing with the single term. Okay, so we already looked at selected problems from 1 to 18. Now I'm going to be focused on picking problems from 19 all the way to, to 32, I think it is. Yeah, and then the 3 at the end, those are long division problems. 33 to 35, they won't be on your test. Okay, so the adding and subtracting, that's 19 through 22. 4.5 and 4.6, that's the multiplying, that's 23. And it goes all the way through, goes through 29, and then actually goes through 30. And then on 4.7, well, 30 is kind of 30 is actually a little bit of this and a little bit of that, a little bit of multiplying and a little bit of adding. All right, and then 31 and 32 are the only two on the review where you're dividing by a single term. Okay, so I'm not going to do them all. You have the answer key, so you can work them out and then see if you're understanding what you're doing. I just want to highlight some of the ones that people struggle the most with. And like, believe it or not, on number 20, this one is usually pretty aggravating. On that one, the biggest reason people miss this is just being lazy and not rewriting the problem without the parentheses. And so this is the way the problem looked. Okay, and then you should be thinking how there's an understood 1, understood -1, understood 1, and just take a moment to distribute to remove those parentheses. So if it's a 1 out in front, nothing really changes. So I'm just rewriting those terms without the parentheses. But in the middle, see that negative on the 1? When you distribute the negative, that's going to change the signs on all of these terms. And usually people miss these two right here. And then when you distribute the 1, you're just going to have 3x squared minus x. Okay, so now you just got this string with a whole bunch of terms, and you need to look for ones that can be put together. So 3x to the 4th, that's the only 1 to the 4th power, so it's by itself. This is a lot of terms. I'm likely to lose track, so I'm going to cross them out when I'm done with them. Next, I'm going to look for the ones with the exponent of 3, and I only see this one. So that's minus 6x to the 3rd. Okay, done with that one. Okay, now here I see a squared, another squared, and another squared. So this is -7, another -7. So I'm up to -14 of these, and then plus 3 of those. So that would be -11 x squareds. See how those have the same variable part? So they would have the same shape piece, and I'm just trying to count up how many there are. So -7 plus -7 would be -14, and then plus +3 I'd be at negative 11x squared. So I'm done with those. Okay, then I've got an x here, an x there, and here I have an x. Okay, so that would be x. Oh, and over here there's a negative x. So actually those two just add up to be 0. So I just have minus 8x on that. And then you need to know you can't combine any further because those have different variable parts. Okay, so that would be your final answer on 20. All right, and then 21 I want to set up because on 21 you've got that subtract from language that we talked about. So subtract, it says to subtract this polynomial, negative 8a to the 5th minus 4a squared, from 16a to the 5th plus 10a squared. So you're going to want the 16a to the 5th plus 10a squared to be first. It's like subtract $10 from $20. You'd have the $20 first, and then you take away the 10. So you got to put that first, and then subtract the negative 8a to the 5th minus 4a squared from it. Now, this is a tricky one because you got a lot of negatives as part of the problem, and then you just, when you wrote it, you have the subtraction sign there, okay? All right, so this is just 16a to the 5th plus 10a squared, but this is an understood negative 1. So when it gets distributed, this becomes plus 8a to the 5th and plus 4a squared. Okay. All right, then I'm noticing that I've got a to the 5ths, and then I have a to the 2nds. So 16 and a positive 8, that would be 24, a to the 5ths, and then 10a squareds and 4a squareds would be 14 a squareds. So that would be my final answer on 21. Okay. 22, I'm going to squeeze in here as well. I just wanted to do all the subtraction ones. That's why you saw a lot of subtraction. That's what people need the biggest review on. Now this one's already set up vertically. You don't change how they're stacked. They're already set up. They didn't use that subtract from language. Problem with this one is you have to be sure you're subtracting that entire second polynomial. You know, you're subtracting all of this. Okay. All right, so what you should be doing is thinking, okay, if I'm subtracting that whole polynomial, then when I distribute the negative, this becomes negative, that becomes negative, this becomes positive, and that becomes negative. Really helps to change the signs. Like if you were subtracting the whole polynomial, that would be like a negative 1 out in front that gets distributed, like I did here, okay? Or like I did up here. It's like having a negative 1 out in front that got distributed. Okay, it helps a lot to write the new sign down. Then you think 9 plus negative 3 would be 6, x to the 5th. Another 9 plus negative 3 would be 6, x to the 4th. A negative 2 and a positive 9 would be 7, x to the 3rd. And a negative 1 plus a negative 3 would be minus 4. And you got to make sure to show me your thinking, show me your work, so I can tell whether it's an arithmetic mistake or whether it's the whole concept that you're lacking, okay? So I can give you as much partial credit as possible. Let me back that up a little bit, see if I can get it to, Okay, so that was the subtracting, adding and subtracting, and then 23 all the way through like 29 deal with multiplying stuff. All right, so I think with the answers that are provided, you should be able to fill in the gaps on like 23 and 24. Okay, I thought I would do maybe 25 and 26. Okay, 25 had 2 variables. So sometimes people don't keep track of that, what happens to that second variable. It also had those negatives that I thought you might struggle with. And then with 26, I wanted to be sure that you didn't take a shortcut on this that wasn't mathematically valid. Okay? All right, so here we have a binomial times a binomial. So we're going to distribute the x to both terms. Okay? So when you do that, you're multiplying. So an x times a negative 3x would be negative 3x times x. Make sure when you're multiplying that you realize you are going to get an x squared there. Okay. It's not x plus negative 3x, right? It's x times 3x. So it's x times 3 times x. There are two x's multiplied together. Okay. If it had been x plus negative 3x, yes, that would have just been negative 2x, but that's not what it is. It's really x times 3, it has a negative 3, x times negative 3 times x, okay? So it's multiplying, so the exponent does become x to the second. Then we do x times 12y, and we just get a 12xy, okay? Now we got to come back. Let me do this one in a different color. Let me do this one in blue. We got to multiply the negative 9y to each of these. We have to distribute it throughout. So you're going to take negative 9 times negative 3, that's positive 27, and it's a y times an x. Let me put it in the same order, that xy order. Okay, and then I'm going to take negative 9y times positive 12 here. And a negative 9 times a positive 12 is a negative 108. And then y times y does become y squared. Okay. All right, so at that point, I'm basically through. I've just got to check and see if I created anything if I had any like terms that could be combined, and I actually do here in the middle. That'll happen anytime you have like the same form. See how this is an x and a y term, an x and a y term? That's why that happened, okay? So we get a negative 3x squared. Both of these are positive, so it's going to be 39xy minus 108y squared. And that would be my final answer on that one, okay? Now, the big thing on 26, I just wanted to remind you of, is that that is really 9x minus 4 times itself. So do that. Then don't worry about the fact that's a special case. See, this is actually in 4-6, but there's no need for that. Just do what we did. You really get to be very good at this, and you do it very quickly. So you might as well just use it and not a special formula. So that's 81x squared minus 36x. Then I come back and I do negative 4 times 9, and I get negative 36 with an x. And then negative 4 times negative 4 is positive 16. See how they were the same form? So I wound up getting like terms there in the middle. And when I put them together, I'll have 72x. 81x squared minus 72x plus 16. Okay? All right, I'll let you do 27 and just compare your answer. That's also from section 4-6. On 28, you're just going to get 6 terms on 28, and then some of them are going to be like terms. 29 is kind of like 26. So on 29, the x minus 4 was to the 4th power. So you had 4 of these. Okay, so my recommendation would be to do x minus 4 times x minus 4. Once you do it for one set, that's what you have in the other spot. So go ahead and take the x and distribute it, and then take the negative 4 and distribute that. So see how you'd get x squared minus 4x. Then we'd come back and do another minus 4x plus 16. So that's x squared minus 8x plus 16. So that's what these two multiplied together would be. So that's what these two are. So I'm just going to bring that over here as well. Okay. All right, now I've got a bunch of multiplying to do. So I've got to distribute the x squared. Okay, then I've got to take and distribute the 8x, negative 8x, to all three. And then I've got to distribute the 16 to all three. Okay, so it's a little messier, but I'm going to do them color-coded like that. So let's distribute the x squared. X squared times x squared is x to the 4th. X squared times, so this times the negative 8x would be negative 8x to the third. Okay, so I did x squared times x squared, got x to the fourth. X squared times negative 8x, negative 8x to the third. X squared times 16 is plus 16x squared. Okay, so I'm done with the x squared. I'm moving on to the negative 8x. So now I'm taking negative 8x times the x squared. Negative times positive is negative. That would be 8x to the third. Negative times a negative is positive. That would be positive 64. X times x, so that'd be x squared. And then I'm going to take, so I did the negative 8x times the negative 8x. Now I'm going to do negative 8x times positive 16. And that's going to be negative, what is that, 128 with just x on it, okay? All right, now see how I'm starting to run out of room? I wish I had, and I'm going to go back and do it. That would be a reason where you might want to stack them. So let me show you that. I could have taken and multiplied those first two, and when I got negative 8x to the third, put it lined up under the cube term. Then when I did the middle two and got 64 x squared, line it up under the squared, and then I had that minus 128 that just was with x. Okay. So then when I go and I do the green one, I can sit there and think 16x squared, line it up under the x squared. 16 times 8, that's a negative 128, that's x. And then 16 times 16 is plus 256. I'm hoping I'm right on those. Forgot to get my calculator out. All right, so now see how everything's kind of stacked, so the like terms are lined up, and here we're just adding these. So we're just going to bring down the x to the fourth, then negative 8 plus negative 8 would be negative 16 x to the thirds. This would be a 32 and a 64, that would be a 96 x squareds. These are both negative, so it's adding those, so it stays negative. It'd be 256x, and then I'm going to add 256 at the end, and I get that when I'm finished. So it looked like it was going to be really daunting, but if you'll do those two, then see how the other two turn out to be the same. And then as you do your distributing, just be careful and maybe stack them like I did to be able to organize it a little more carefully. Okay. All right, let's go ahead and keep going on this. I want to go ahead and look at question number 30, which deals with an area and perimeter problem. Okay. Go ahead and do it on another page. Okay, so on this one, we have this square, and we know each dimension is 6t plus 2, and this is number 30. And question A says, what's the perimeter? And question B says, what's the area? Okay, so for the perimeter, that's just adding up all the way around. So every side would have been that long. So perimeter would just, of a square, would just be taking 6t plus 2 and adding it all the way around. You can literally write that 4 times. Or you could have been thinking, I'm just going to do, 4. It would have been okay to be thinking 4 times 6t plus 2, since they turned out to be the same. And like if this had been a rectangle where maybe this is 6t plus 2 and maybe this is t minus 5, you would have a t minus 5, a t minus 5, a 6t plus 2, and a 6t plus 2. You would have had 2 6t plus 2s, and you would have had 2 t minus 5s. Okay, so that's a what if. That's not what the problem was. Okay, but anyway, so you could think about it either of those two ways, and then see how it would turn out to be 24t. And you could have done it by distributing or by adding up the 6 t's. And then when you add up the 2, see how you get 8. And you'd have gotten the same thing if you had distributed the 4. That's part A, that's the perimeter. Perimeter is still a length. So the exponent's, not going to change, it stays t. Now area is when you do length times width. So this one should be the length times the width. They just happen to be the same. And if it had been this example, then you would have multiplied 6t plus 2 times t minus 5. But that's just a what if. All right, so I'm going to multiply those. It's going to be 36t squared, 12t, another 12t, and a 24, because I'm doing that foiling process we looked at. And then I have like terms in the middle. And so my final answer to this turns out to be 36t squared plus 24t plus 24, okay? All right, so this part right here is actually 4, 4, and the area part is actually in 4, 5, 4, 6. All right, so let me go ahead, since we're almost through, and handle dividing part 1, where you're dividing by a monomial. So this is 4.7, part 1. You're dividing by a single term. Okay, no pluses or minuses. Okay, so the key idea there is that you should take a moment Okay, this is how the problem looked on the paper. This was number 31. This is the step that you should do. You should take a moment to just divide that into each term. Oops, I forgot the X on that. So 2x to the 5th has to be distributed into each of those. So just write it down. And then what you've got are 4 problems that come from section 4.1, the exponent section. This is just 8 divided by 2. That's going to be a 4. Knock out 5 of those x's from the 8 on top, you'll have 3 left. Okay. For the second term, 4 divided by 2 would be 2. 5 of those x's cancel out. I'll have 2 left. Here, this one's a little tricky sometimes. There's 5 x's on top and 5 x's multiplied together on the bottom. That would actually equal 1, okay? But then 10 divided by 2 would be 5. And then what happens on this last one is you have 4 divided by 2, which would be 2. But then see how there's 2 x's left in the denominator this time? The bigger number's on the bottom. And so your answer the way that term simplifies is you'd have 2, but you'd have x to the 2nd in the denominator. 2 would be on top, x to the 2nd in the denominator. And then those are not going to be like terms. You can't do much with that. And that would be your final answer. Okay. So let me go ahead and work out. Actually, I think you'll be okay. There's nothing that tricky about 32. So I think you'll be okay since you have the answers. You do the same thing. Just be sure you write the 4m to the 3rd n underneath each term, and then you just simplify. Okay. All right, so this video covered sections 4.4 to 4.7, part 1. Now I'm going to do a video on long division as well. It's not going to be on your test, but I'll expect you to complete that homework as soon as you finish your test. All right.